Hello and welcome back to today's video. So we're going to be having a quick look at the integral of e to the 2it from 0 to pi on 6, and we're integrating that with respect to t. So this is the first complex integral we've done on the channel, and I hope to do a lot more in the future. So if you do enjoy today's video, please leave a like, subscribe, and let me know what you'd like to see more of in the future. So let's dive right in. So we know that when we are integrating an exponential function, well, we know that we must divide by the coefficient of whatever variable we're integrating with respect to that's in that index up there. So putting it in written terms, that just will simply become, well, e to the 2it, that remains the same, and divided through by 2I. Okay, nothing too crazy there. That's exactly what we should know from probably year 10 or year 11 algebra and introductory calculus classes. So we are taking that from 0 to pi on 6. Okay, so fantastic. Now we're pretty much there, to be honest with you. All we need to do is just quickly substitute these values in. So let's see what happens now. So we'll say that this is now going to be equal to, well, e to the 2I pi on 6 all over 2I. And then minus, well, e to the 2i0 is still e to the 0, which will just become 1 over 2I. Okay, fantastic. So one thing that we need to take a quick notice of, we know we can quickly simplify this, get rid of that 2 and that 6, and just make it a 3. So we're going to be using Euler's formula, and I know I'm probably butchering the name. I've heard it mispronounced a million times in my life, and I'm sure I'm doing it again right now. But this man himself, so Leonhard Euler, I believe it's not Wheeler or Euler, as many people might say. So what his formula says is that if we have e to the power of ix, that is going to be equal to cos of x plus I sine of x. Okay, so we're going to use that information here to rewrite our problem now. So what we notice as well is that we've got a common factor of 1 over 2i, so we're going to take that out the front. And now let's start writing out what we've got left over. So e to the I pi on 3, well, from Euler's formula, we know that we can just write that out as cos of pi on 3 plus I sine pi on 3. Okay, and then we'll just have that minus 1 on the end there as well. Okay, fantastic. So all that's left now to do is quickly let's evaluate what is cos of pi on 3. Well, we know that that's just going to simply be a half, and now sine of pi on 3, well, that's going to become a root 3 over 2. So we'll say I root 3 over 2, and then a minus 1 on the end there as well, of course. Okay, so let's quickly just expand these brackets out, and let's see what we get. So we'll end up with 1 over 4i plus root 3 over 4, since the i's will cancel out, and then minus 1 over 2i. Oops, no brackets there. Okay, so now let's just quickly collect like terms, and we always tend to put the real value out the front, so this is going to be root 3 on 4 as our first term, and then 1 on 4i minus 1 on 2i. Well, we can simply rewrite that as minus 1 on 4i. And it would be completely fine for us to leave it at this stage and just kind of leave that as our final answer. That's not wrong, but we can neaten this up a little bit. So what I'm going to do is I'm going to look at that 1 over 4i, and what we can do here is we can just multiply that by I over I, since, well, we know that's just going to be equal to 1, and we can always, of course, multiply anything by 1 and have it remain the exact same. So that's what we're going to do here. And so again, quickly rewrite out our real part, root 3 on 4. And now let's see, well, I times I in the bottom, well, we know that I squared is negative 1, so that will now change that sign there. So that means now it's going to become a plus, and the I is in the numerator now, so I over 4. And that's it. And so there we are. So just a quick little fun example to go through in terms of our complex integration and looking at how that all works out. Very much the same sort of thing as your standard real integration. The only thing that we really need to take care of is when we're using Euler's formula. Apart from that, everything kind of just goes through very procedurally. So if you have enjoyed today's video, please leave a like, subscribe, and comment. I really do appreciate it. And please let me know what you'd like to see more of in the future. And as always, stay curious.